time series ARIMA, right? Univariate model, right? Univariate ARIMA. So what do you mean by univariate time series model? First of all, what is a time series model? Why we need to use the time series? Time series is meant for forecasting. The next question is, what is the difference between forecasting and prediction? Using linear regression, logistic regression, even we have seen the gradient boosted decision tree and random forestry, using which also you can make a prediction, right? Using which we can make a prediction. Prediction is kind of a long term. The time series is kind of a forecasting. Okay, so anything if you want to forecast in the short run, that is called your forecasting. Just keep it in mind. And so, what are the components are available as part of the time series? How many of you remember the components of time series? The trend. One is trend, other one is seasonal, and next one is cyclic and irregular. This is how the interview question will, they will ask questions. Okay, and what are the components are available? So, what is a trend? Next one is trend. What is a trend? It's something like upward or downward movement in average or mean value of the forecast variable. Okay, that is what trend. And the next one, seasonal. You know very well, seasonal. Every year, if you see the during the summer time, the ice creams sales are very high, and during the winter, the sweater and woolen clothes are sold high. Okay. So in this case, in the case of seasonal, you can find the fluctuations that are repeatedly, usually within a year, you can see it, right? Repeated fluctuations, you can see it, which means every year, October or October month in India, the festival is there, right? So the Diwali festival is there. So that time the sales is high, sales is going. This is common in almost all the year. And similarly, during Christmas, every year, the December, you can see the repeated pattern. If you take last 3 years or 10 years data, sales data, each year you can see that every year, every end of the year, you can see that the sales is peak. That is your seasonal. And the cyclic is also kind of upward or downward movement in the average of this one, the cycle. And what exactly the difference between cyclic and the um, this one, the trend? Cyclic, it shows fluctuations at any point of the year. That is what your cyclical variations. What do you mean by fluctuations at any time of the year? Right. So the cyclic variations basically it contains four phases. You have something called prosperity, recession, depression, and recovery. Right. So your sales is really doing good job. Suddenly some recession happen and it goes down and again it is recovering back. That is kind of a cyclical variation. And you have something else called the random movements. This is something like COVID kind of situation, erratic and unforeseen, uncontrollable in nature, like earthquakes, COVID. Those times the sales was not good. Okay. Right. So this is another kind of movement. It can be seen in the case of time series. Which one? The irregular movements. Okay. This is kind of unforeseen, uncontrolled. Right. The outcomes of irregular movements are something like unforeseen, erratic due to COVID or unforeseen things. Right. Natural disasters like earthquakes. In that kind of situation, you can see some kind of irregular movements. Okay, it is something unpredictable, something like that. Okay, so the you understood the difference between cyclical and random movement. Cyclical is basically having four phases. It gives us the fluctuation at any time of the year. Okay, whereas the irregular movement is something like it's a very rare situation, right? The sales is not good because of riot or earthquakes, floods, tsunami, right? So those kind of things, the sales went down suddenly. And seasonal, very well, trend is, well, upward and downward movement is nothing but your trend. So these are the components that are part of your um, these are the part of these are the four different components that are part of your time series. And also we discussed about different types of algorithm. ARIMA, right? Auto regressive integrated moving average. We discussed about the equation also, and we have something else called Sarima and vector autoregression, exponential smoothing models, profit model. We discussed about the AR model, ARIMA, the last weekend. And Deepa, are you that Deepa was asking that she wants the ARIMA to be repeated one more time? She was not able to have a complete hold on the ARIMA model. Look here, this is the equation. Okay, this is the equation for the ARIMA model. So univariate time series analysis. We discussed about the univariate time series analysis. This is an equation for that. If you see here, so in this case, what is yt minus 1, yt minus 2? These are all called your lag 1, lag 1, lag 2, etc., lag n. Okay, and this is your lag 1 error, lag 2 error. So the ARIMA combines two parts here. One is the autoregressive. This is your autoregressive. And the MEA is moving average. It combines these two things, and I stands for difference, differencing. Deepa, I'm repeating this for you only. The ARIMA model is also called as a box Jenkins model. See, the autoregressive YT is a linear combination of last p values, whereas moving average is a constant value plus the effects of a dampened white noise process over the last time steps. Okay, still you might be confusing with this one. Autoregressive, something like lag one. So as I discussed in the last session, when it comes to univariate time series analysis, right? You don't have any independent variables. In the case of the traditional machine learning, supervised machine learning algorithm, we know the independent variables. With the given independent variables, we will be predicting the dependent variable. But when it comes to the time series, we don't even know the independent variables. We are not sure. There is a lot of uncertainty. Even if you know the variable, there is a lot of uncertainty whether we can use that variable as a independent variable. Like I said, the microeconomic factors like GDP, inflation, these are these are the factors also influences your forecasting. Like in the case of housing price, the size of the house and age of the house and area of the house influences your housing price. If the area is, let's say you are living in a posh area and age of the house is just 1 year old and size is 2000 square feet, the price is very high. And if it is not posh area and the age of the house is 15 years and size of the house is, even though the size of this 2000, but the price is not that good, right? So, so these are the factors we know very well can influence that, but still using the feature selection technique like RFE, or we can use the random forest feature importance or XGBoost feature importance, using which we can find out the features that have higher predictive power. With that, we can predict the dependent variable. When it comes to time series, so we know that. So, for example, if I ask you Infosys stock price and Wipro stock prices, right? So, what influences stock price? First of all, what factors that can influence? Like this, right? What factors which can influence the stock price? The company revenue, quarterly revenue, revenue or so, right? But we wanted to forecast the near future. Unlike the supervised machine learning algorithms, here we want to forecast the, for example, I want to forecast what is the stock price for the Infosys or Wipro for the next 5 days. Next to 5 days, short term. Anything short term is forecasting. Remember that way. So in that case, what will happen is you need to, if you wanted to fit this like linear regression model, you need to know the independent variables. And you know one of the independent is the quarterly revenue, company performance, how the company's Infosys is performing, how Wipro is performing, based on which we can, these factors can help us to determine or predict what is going to be the stock price. But the GDP and inflation, these are the macro economic factors. So you will not get on a daily basis what is the GDP inflation. You cannot get it on a daily basis. In that case, even if you include it in your model as an independent variable, it is not the right way of doing it, right? So in that case, what we do is we take the dependent variable, which is nothing but the stock price. I wanted to predict or forecast, sorry, I want to forecast the stock price. In this case, let's Infosys yesterday, yesterday and day before yesterday, right? What is the stock price? Here you have something like 4,024, 4,013, something like that. Okay. So these are yesterday, day before yesterday. You have the values here. But since you cannot use GDP and inflation because you cannot get it on a daily basis, if you cannot include it here, it doesn't make any sense. Since what we do is we take the yesterday stock price of Infosys day before yesterday, right? Or last 7 days or last 5 days stock price of Infosys, you'll take it. With that, we are going to forecast for the next 5 days what is going to be the stock price for Infosys. Similarly, we do it for other companies. But in this case, the stock price is a dependent variable. In one way, this variable itself acts as a independent variable. The yesterday price, you are using yesterday price and day before yesterday price and prior to day before yesterday. The last 5 days stock price you are taking it. Okay, with that you are going to forecast the stock price for the next 5 days of your Infosys stock price equity. Okay, so in this case, the dependent variable and independent variable is stock price itself. In simple time, right? To make it simple, this is how we use it, right? So that is what it tells, this equation tells us the time, right? So what is the forecasted price for a given time period or time, right? So here in this equation is a constant value. Here you are multiplying the by pi 1 and yt minus 1. This is nothing but lag 1 yesterday, and how many number of previous days data that we need to use it, value or the stock price, we need to use it in our model to make the forecasting. You cannot blindly use a lag one. What do you mean by lag one? Yesterday. Lag two is day before yesterday. Okay, so how many days stock price should I use it in order to do the forecasting? How will I come up with the optimal number of lags? Right, so that is what your AR talks about. So this is also called as PDQ in the ARIMA function. Three arguments: P is for AR and D is for differencing and Q is for ME. Okay, what is E? E is okay. Yesterday, what is the error? What is the actual value minus the forecasted value? Actual value and the forecasted value, and what is the difference? The lag one error, lag two error, and so on. So with the combination of these two, we'll be able to get the forecasted value for any given time, right? So that is what your ARIMA model. So now the question is, okay, AR, how many lags that I need to use it in order to make a forecasting? And similarly, in addition to that, you need to know the lag one, lag two error also, that you need to specify. You need to supply the values for PDQ. How many number of lags that I need to take into account, how many number of lags related errors that I need to. So let's say 3 days or 5 days, here also 3 days, 5 days, or 0, you need to do it. What is the middle one, D? This is what I was talking about. The prerequisite to forecast. To make a forecast, your data set should be a stationary one. It should be stationary one. Your data set should be stationary one. If you find something like this, it is non-stationary, because the prerequisite, or the first prerequisite to fit the ARIMA model is the data set should be stationary. What do you mean by stationary? The mean and variance should be constant. You know what is mean, what is variance? These two are supposed to be constant. When you look at this, when you plot the data here, So you can easily make out that the mean and variance is almost, both of them are almost constant. Hence, this data set is stationary data. Hence, we are good to go with fitting the model. If the data is not stationary, in this case, it is not stationary. Hence, we cannot use this data to fit them or train the ARIMA model. Why it is not stationary? Because if you take the mean of this data and if you take the mean of this data, these two are completely different, right? If you take this data and if you mean of this one, if you take the this value mean, these two are completely different. Whereas if you take this data set and if you take this data, the mean are more or less same and the variance, the mean is same, the variance is also same. Okay, hence it is kind of constant. Hence this data set, given data set is stationary. Then you can go ahead and fit the model. But still, in the ARIMA, in the sklearn, or you take any R or any statistical language, you have some ARIMA function. You need to say how many lakhs that I need to do, 2 days data and differencing. Do I need to do differencing? Okay, if it is a non-stationary, you need to do differencing one. How many number of times I need to do differencing? And next one is the the error. Let's say 0, the moving average is 0 here. Okay, you can specify this way. But nowadays we have something called auto ARIMA. With that, it automatically helps us to find out the optimal value for this PDQ. With that, you can, this one, the auto ARIMA makes our life easier. It automatically estimates the optimal value for PDQ. With that, we can make a forecasting. Okay, so with that, you can do forecasting. So the end of the day, like in the case of linear regression, the OLS method is used to estimate the optimal value for your slope and intercept. It is taken care automatically. But here, we need to find out the optimal value for the PDQ. But we have a luxury now. We are using auto ARIMA. With that, it automatically finds out the optimal value for this one. Okay, now the question is, without using, let's say we are not using auto.arima, how will you find out the optimal value for PDQ? So we know very well what is AAC. You fit this model with this value, some value, and check the AAC. You know very well. When you use this summary, it gives you the AAC. If the AAC is something like 1032, something like that. And then you use another model, ARIMA. Here you give some other value. For example, 3, comma 1, comma 0. So what is the AAC for this? This AAC is 1001. Of these two, which one is less? 1032 or 1001? 1001 is less. Hence, these values are optimal. But still, you need to keep change the values and compare with the AAC of this model with the previous model. It is a time-taking process. Hence, we will leave it with something auto.arima. So that one is helpful to determine the best values for PDQ. Okay, now you understood the P is for autoregressive and Q is for ME. What is D? D is differencing. Okay, now the question is, what is differencing? The middle one. Let's say my day, when I plotted my data, let's say I was given something like column like prices. When I plot the prices, stock prices, I could see something like this upward trend. This data is not in stationary because the mean and variance is not constant. Visually, by looking at this itself, we can say upfront this data is not stationary. So then we cannot use it. Is there any way if I can convert this stationary? Yes, that is possible. How do you convert this? By taking the difference. Okay, by taking the difference, yesterday's stock price minus today's stock price, right? By subtracting, finding out the difference, you can make it stationary. You can convert the non-stationary data like this into stationary by taking the difference. Now how many, supposing, let's I'm taking the differencing. Even after taking the differencing also, I can see that something like this. You need to take the difference one more time. So that is where, you need to specify the value, how many number of times you need to take the differencing. If you say, already I have difference, I took the difference 0. Okay, I want this to take the difference, right? So this is to convert your non-stationary data into stationary data. That's all. It's very simple one. This is by visually looking at this, we get to know that the given data is stationary or not. But apart from, there are some statistical. There is a statistical test called the augmented Dickey-Fuller test, ADF. ADF test is there. You know very well in statistics, as I told you, right? So if you conduct any statistical test, that will return the p-value. If the p-value is less than alpha, we are going to reject the null hypothesis. When it comes to augmented Dickey-Fuller test, so here the null hypothesis is the given data is non-stationary, and if the p-value is less than alpha, we are going to reject it, and then we conclude that it is stationary. Okay, this is what the ARIMA model is all about. I don't want to talk in depth. We will jump into the coding part. With that, you should be able to understand very clearly. Now you got some amount of idea, right? Some fair amount of idea about this one. What I will do is I'll jump into the this one, not Power BI, Jupyter Notebook. Here we will take a look at how to do forecasting using sklearn. Here what I do is I just use import numpy. So this is all the required packages, the commonly used packages only I used it. The warnings, you know very well. Unnecessarily it will give some warnings, right? So to ignore that one, don't display the warning kind of thing. You can use it. I have the data set called Nifty underscore TSV. The colon, I don't know if I still have this data set there. Okay, SPD. So this is my first three records of my data set. Yes, still this file is available here. And here I have three columns. One is date and prices and returns. To other prerequisite to do forecasting is, in the date column, you're not supposed to have missing values, which means, for example, if you take January month, all the days, each day's data should be there. There should not be any gap here. You're not supposed to have blank values, and you need to, yeah. So these are the conditions, right? These are the prerequisites. Even though you don't have any trading happen on a specific day because of holiday, all the things, still, it should have the date column should be there here. So now we can see that we have date column, prices and returns. What we will do is this is my Nifty data sets. So the stock market, a specific, info or something like that, right? So their stock prices and what is the returns. So what we will do is we'll first do the forecasting on the prices column. So now what I do is I need to check whether this column, I want to do a forecasting for prices, stock prices. In that case, I need to check whether this column prices is really fit enough, sufficient enough for me to fit the ARIMA model. So for that, I need to use, the visualization. I just simply use PLT dot plot. Good. So prices, I can see that, somewhere it went down and suddenly it is going up. So we can see a trend here. We can see a downward and upward movement, but it goes up, up. Okay. With this, I can understand that this data is not stationary, because we can say afford. If you take the average here, and if you take the average here and here, it is not same. Just by looking at this itself, we can say this is not, this data is not good enough to proceed with doing a forecasting using ARIMA function. So what I do is I'm going to use something called, this is visually, just by visually looking at this data itself, we get to know that it requires some kind of treatment, because with this data we cannot do forecasting, because it's a non-stationary data. What is stationary? The mean and variance supposed to be constant. Okay. Now what I do is, instead of going by the visual, I'm going to do some kind of test. Instead of relying on the visual itself to confirm whether the given data is stationary or not, I'm going to conduct the statistical test. Let's see, I say df out, AD Fuller, NIFT, sorry, the first argument is we have an argument called auto lag is equal to AIC, archaic information criteria. So now what I do is I just df output. I'm going to use something like series. Ignore all these things. Don't worry about all these things. Okay, series is supposed to be capital S. So you know what is series and what is data frame. Okay, and don't worry too much about the coding part. Understand the mechanics, how it works. And I'm going to use index is equivalent to test statistic. Vast values is for, okay, here AD Fuller NIFT prices, auto lag AIC, and df out 0:4, and index tested is 1 to 3. Here index implies 3, values is 4. Okay, here I did not. Okay, I'll need to use one more thing. Number of lags used. Okay, now it's working fine. All we need is just the p-value. As I told you, the H sub 0, the null hypothesis when it comes to this one, right? ADF test is um, so what is the alternative hypothesis, right? It is stationary. It is stationary. If you reject the null hypothesis, then it is going to be the stationary. We are going to convert the stationary. And if you fail to reject the null hypothesis, then the given data is not stationary. And if you see the p-value, what is p is less than alpha, right? Alpha is there in our mind, 0.05. And what is the p-value? 0.99. 0.99 is p-value. P-value here is 0.99 is not less than. Instead, right, it is greater than my 0.05 alpha value. Hence, I fail to reject the null hypothesis, and I'm going to conclude that the given data is not stationary. Test also, we are going to conclude that the given data is not stationary. Okay, what is the next step? Next step is I'm going to use my ARIMA model. Okay, and I'm going to directly jump in here. But apart from this test, we have something called the rolling mean and rolling standard deviation, right? If there is something called rolling mean, and what I do is we will use that technique also, rolling mean and standard deviation. Instead of variance, here we are just using standard deviation. Standard deviation is a STD function. There is an STD function available with this. Okay, and I just click on run. Okay, fine, no error. The next one is we are going to plot this value, plt dot plot I just say plt dot show. Okay, here, what is the error? I'm getting it now. And invalid RGB argument. Okay, here, see, just a simple spelling mistake is through this much of this many lines of error, right? So it's just error read. Look here, now we can see that this is the original, and this is the thing. Okay, is rolling mean same as moving average? Yes, it's kind of the moving average. Okay, so basically, rolling means is nothing but creating a rolling window with a specified size. What do you mean by rolling window? Rolling window is window. What is window? Window is a time duration. Okay, supposing your rolling window size is 3. Okay, what will happen is, let's say you have the data set. This is what I explained in the last session. And for example, here, you have something like, day 1, day 2, day 3, day 4, day 5, day 6, day 7. Here you have something called day 7, 100, let's say 105, and then 106, 104, 106, 108. On a daily basis, the prices will change, right? So 110. If I ask you to take the rolling average of 3 days, what will happen is it is something like this. The rolling window is something like this. First, what you do is you take the rolling average for the first 3 days, and then you'll put the you have another column, right? Average or something. Here you will put the average of these three things. You say 100 and something like that, 111, right? So you say 100 and hypothetically, 104.3 something like that. First 3 days, and then the next time what will happen is you take the rolling average, or let's take this example, 7 days rolling average for 7 days, rolling average for 7 days. First 7 days it will not, right? It in the eighth day you will find, let's say, 102. First 7 days average will be displayed here. Okay, 7 days average. Let's say I put something like 109 something like this is the average. And then what will happen in ninth day? It will remove the earlier one, and then it take the average of the 7 days data from today. Okay, from today and going back about 7 days. Okay, and let's 10th October. Let's tomorrow is 10th October, and if you want to do rolling 7 days, right, it will take the average 7 days by leaving these two things. Okay, so this is called your rolling average, rolling average or rolling window average. Window is nothing but the duration. We are going to tell how many number of days we need to do the rolling average. So once you specify the value, right, 7 or 7, in this case 7. So what will happen is every day, what will happen is it will go and take the 7 days data including today. Okay, and then it will remove the earlier one from your data set. That is what your rolling average. Okay, this is kind of moving average. Yes, Mala, correct. So by with the rolling mean itself, we can see that it is not stationary. Hence, it requires some kind of treatment. We need to take the differencing. So I'm not doing the differencing everything manually. What I do is I will leave it with. So to conclude, the plot visually also we have concluded that the given data set is not stationary, and also with IDF Dickey-Fuller test also we have confirmed that the p-value is not less than alpha. Hence we fail to reject the null. We confirmed that it is not a stationary data. And now what we with the rolling mean also we are able to see the same thing. Okay, next one is I'm going to use the stats models. Import stats models dot API dot API as I just say SM, and this is the common alias we use it. Model is equivalent to sm dot psa dot arima is the capital, and here I say what is our data set name? Data set name is NIFT. Prices, and the next one is order. Order is equivalent to 1 comma 1 comma 0. I'm going to specify it here. And the next one is model fit. Here model dot fit. Okay, that's what. And the next one is print model underscore fit dot summary. Okay, now like linear regression and logistic regression, when we used the stats models, it was giving the exhaustive information about your model. In this case, I have used the ARIMA model. The first argument, I have used the column name prices. For this only, we want to do forecasting. Order, you remember order, I was talking about the order here. In the ARIMA model, where is it? The PDQ, I was talking about PDQ. So what values you need to use it? P is related to AR and Q is related to ME and D is related to I. And here what I do is, since this given data set is not a stationary data, we need to convert this as a stationary data. In order to convert this, we need to take the difference. So we don't have to take the difference, we don't have to add a separate step to do the differencing. Instead, I will leave it with this algorithm itself, ARIMA. Here, look here in the order. This is P. Take yesterday's data, and don't use any MA, moving average. You put 0 here. One is you take differencing, so that this one will get converted as a stationary data. Okay, only when you convert this stationary data, then you can fit the model. Okay, now the next step is fit, model dot fit, like other things. See, all the supervised machine learning algorithm, if you want to train it, only two lines here. One is you need to initialize the model name. Next one is fit method. That's all. And if I click on it, only the challenge is understanding the algorithm. Look here, we got a lot of information here. The header displays Sarimax results when your model may only be a vanilla autoregression. Okay, this SARIMA stands for seasonal autoregressive integrated moving average with exogenous regressors. Don't panic. What is exogenous? We have something called endogenous and exogenous. Exogenous variable is the explanatory variable is nothing but the independent variable. Okay, and endogenous is nothing but your so the endogenous is something like any variable in your model that is correlated with the error term. That is what your endogenous, exogenous. Forget about these two terms. Any of it is recording it, you can learn it. You can, when you hear it more than one time, you'll be familiar with this one. The next one is with the dependent variable. We have used the dependent variable as prices. And the next one is the model. Model is ARIMA 110. What values we used it for PDQ 110. And the daytime, right? It is simple one. And the next one is the number of observers. How many number of observer records we have used? 255 records are there. And the next one is the coefficient. If you see the coefficient here, right? The independent variables or the constant beta here, right? So AR dot L1 and the error term, sigma 2 is something like your error term, okay, here. And the next one is, so if you see here L1, and if you look at the corresponding p-value, p is less than alpha, hence we are rejecting alpha. We are going to conclude that this variable is statistically significant. In this case, lag 1, yesterday price only it took it. With that, it fitted the model. And yesterday, where the stock price value, whatever you took it, it is significant, which means it is helpful in terms of forecasting. Okay, that is what. So after looking at this, right, so the output, we don't see any mistakes in our model. So next, we will move on to the another step and analyze the significance. And here, okay, good, right? So the AR dot lag when is 2.218. And the next one is the L-Jung box. You can see that. So usually they pronounce this one as, young, right? So young box. And or sometimes they call it a box Pierce test. Box Pierce test. Right. So the here in this case, the probability of Q is 0.12, and the p-value is 0.73. Okay, so since the probability is above 0.05, we cannot reject the null hypothesis that the errors are white noise. Okay, that the errors are white noise here. And the next one is the AAC. Like I said, the AAC here, sorry, I forgot to discuss the AAC, the archaic information criteria. This is the one helps us to determine the strength of this model. Okay, this AAC basically penalizes the model for adding parameters. When you keep add, for example, if you put 2 here, so AR.L1, AR.L2 will get it. Okay, 2 lakhs you are using it. But with AAC, you can find, for example, I'm going to create, I just copy and paste it here. I just say something like two differencing 1 time and 0. So this is a different model, right? This is another model. Okay, and if you see here, AR L1, AR L2. Okay, and both of them, only this one, according to this, only use this one L1. Don't use lag 2 because the p value is greater than alpha. Hence, it is not helpful. Now let us check the AAC value. AAC value is 2149, whereas the AAC is 2147. Of these two models, which one is having lesser AAC value? This one. This one is good model because the second L2, since we mentioned 2 here, right? It takes into account of the lag 2, yesterday to and day before yesterday price. Okay, and the day before yesterday price is not much helpful in terms of forecasting, because of which it causes some error, right? And hence the AAC value gone down. So with the AAC itself, we can find out the best fit model of these two models. So this is a separate model. This is a different model. These two different models. How do I find out which one is the best model? AAC. The lesser the value of AAC, so 2147, you're 2149. Of these two, this is the smaller value. Hence, we'll go by this one. But still, we have something like whether if I change it to some other value, will it will that bring down the AAC value further? So how can, let's say if I say moving average, all the values 111. Okay, I'm not going to change it to 2 and all. If I say 1 1, will the AAC, here 2148, but here 2147, but still this one outperforms because the AAC value is lesser compared to other things, right? So that is what we can understand with this. So AAC basically penalizes a model for including parameters. In this case, lag 1, lag 2, right? So when you include more than one value, right, a variable or something like that, it penalizes us. Next one is Bayesian criterion, information criterion. This is also same as your ASC. Okay. So like AAC, BAC also punishes the model for complexity, but this is the one incorporates the number of rows in the data. Okay, apart from the columns, AAC, which how many number of P, what value should I use it for P and D, Q, to get to know that whether the model is good or not, right? So we use AAC, but in the case of AAC, it takes into account of the P, D, Q. But BAC, in addition to AAC's thing, right, it takes into account of the rows also. And the next one is the log likelihood function. It identifies basically the distribution that fits best with the sample data. So while this is useful, the AAC and BIC, right, these two metrics punish the model for complexity, which helps make our ARIMA model parsimonious. This is one of the term that is used by parsimonious. A lot of fancy terms are used in the case of machine learning, and deep learning and all. But don't panic. Parsimonious is nothing but make your model simple by including only the necessary number of independent variables. Don't include so many independent variables. Don't include less number of independent variables, but include only the required number of independent variables. You know very well, in the case of univariate time series analysis, as the name says, univariate, single variable, right? Here we are not using any independent variables, but we are using the p value and q value to do the forecasting here. Okay, so use the optimal value for the p. Okay, and in this case, 110 is good. With this itself, we can do it. And apart from this, we have something called auto.arima. I don't have that package name. Probably I'll check and come back to you later. Okay, so that auto.arima is automatically determine the values, the optimal values for PDQ. Probably I'll check and come back on that one. So with this, you are able to understand how we can do forecasting. Okay, how we can fit the model, how we can interpret the model output. Now with this, you are able to understand. Fine. The next one is